Okay, so in the last video, we looked at the confidence interval comparing two means. Now we're ready to look at a hypothesis test for comparing two means. So let's review what we were doing there. If I'm looking to see if two groups are different, that's the same thing as looking to see if their means are different from zero. In other words, if I subtract them, if this one's bigger, then the result would be positive. If this one's bigger, the result would be negative. If they're exactly the same, the result would be zero. So we want to know, is it different than zero? So we need the standard deviation. We looked at that formula last time, said if we don't have it, we call it the standard error, and we substitute in our sample standard deviations. And then run a two-sample hypothesis test that follows a student's t-distribution. This is the same t formula from before, just one population. Our sample mean in this case is y1 minus y2, minus the population mean, in this case is the first population mean minus the second, over that standard deviation, which in our case is the standard error. And in order to do this analysis, we need to make sure that the data is collected randomly. We need to also make sure that it looks roughly unimodal and symmetric, that nearly normal condition for both groups, and that the groups are independent. If we do that, we can form a t-interval, which we did in the last video. And we said there's a complicated formula for the degrees of freedom, so we're just going to let our calculator do that. And we looked at these two examples in the last video. Now we're ready to talk about doing the hypothesis test. So with the hypothesis test, we're going to do a two-sample t-test in your calculator, okay? Again, we have to make sure all those conditions are met. It's the same t-statistic. This is the difference between the means, or difference between our sample means, minus the difference between the population means over the standard error. Okay, now, if the variances are the same for the two groups, we can do a pooled t-test instead. Most of what we're doing in here is not going to involve pooled t-test, but the information is in your textbook that you can read regarding that. But a lot of times when we're looking at these two groups, the variances will not be the same. So the pooled t-test is only for when we can assume that the variances of the two means are equal. So now let's look at an example on page 625. I want to look at problem 10. So I'm going to go right over here to the textbook, and the study of the new CPMP mathematics methodology described in exercise 7 also tested students' ability to solve word problems. This table shows how the traditional and experimental group performed. What do we conclude? All right, so in order to do our analysis here, we first need to check to make sure that our conditions are satisfied. Notice this doesn't say anything about how the data was collected. So I would need to state that one thing that we're doing is assuming that there was some randomization procedure used to collect the data. Otherwise, I can't proceed with this analysis. Now, the next thing is the nearly normal condition. Well, with just the mean and the standard deviation, I can't really check to see if the data looks unimodal and symmetric. I don't have a graphical display, and I don't have the rough data where I could make my own. But look how big these sample sizes are, 320, 273. Both of those are large enough that I'm not really worried. Because remember, we said once the sample size gets over about 30 or so, the means start to follow a normal distribution. So I'm not too worried about the normality issue here because the sample sizes are fairly large. But ideally, I would want to graph it and check it, okay? So those two conditions, we can put those caveats on it. The third one is that we have independent groups. Well, if we look at this here, we have one group of students being taught by one method and another group of students being taught by another method. Those are independent, so I'm not worried about meeting that condition. So we would say, yes, with those caveats that we mentioned, we can go ahead and proceed with analysis. So I'm going to look for a difference. I'm going to go over here to my calculator. I'm going to go to Stat Key, over to the test, and option 4 here is my two-sample t-test. Now I don't have the data in list, so I choose the stats option. I already entered all of it for you. The hypothesis test that I'm going to do, well, I need to decide. So we go over here and we say, what are we looking at here? By the way, the word problem says, what do we conclude? It doesn't say we want to know whether they're better or less or anything like that. So when I'm looking at forming my hypotheses, my null hypothesis, my null hypothesis is that the two groups are equal. So I would say my mean for the first group is equal to the mean for the second group, or equivalently, that the difference is 0, either way, right? So I could have also written it as mu1 equals mu2. That's saying the same thing. Now the alternative hypothesis, though, I don't necessarily know that traditional or the new method is better. I'm just looking to see, is there a difference between the two? So I'm going to say is not equal to 0. So I'm going to do a two-tailed test. So with the two-tailed test, remember, that means my T critical is over here somewhere, and the negative T critical is over here somewhere. And this is my reject region, this is my reject region, this is my fail to reject region. So I'm either going to compare the T to the T critical and see which region it falls in, or equivalently compare the probability to the alpha. Now my alpha is the area under the curve. This would be half of it here and half of it here since it's two-tailed. So if my alpha is 0.05, right, then I'd have 0.025 in each area. Okay, so now let's go back to the statistics for a moment here. I'll keep that. And I've filled in all of the information. We're doing a two-tool test. No, we're not going to pool. Let's go down and calculate. And this is what we get. Notice my T here is 1.406, and the probability P that goes with it is the 0.1602. The degrees of freedom is 590.05 right here, and it shows me my summary statistics, okay? So let's go back over here, and let's write down those important bits. So the T that we found, is 1.406, and our degrees of freedom is 590.05. And our probability that goes with this T was 0.1602. Okay, now I can either compare this T value to the T critical, which I didn't bother to find, but I could look up in a chart. But because equivalently, I can compare this to alpha. This is bigger than the alpha of 0.05, so that tells me I fail to reject. My T value is over here in this fail to reject region. This is where the 1.406 is, okay? All right, so if I fail to reject, what does that mean here? We do not have evidence to indicate a performance difference on word problems between the two groups. Okay, and that's it. We're done with the hypothesis test. Now let me mention one thing though. In our last video, we looked at confidence intervals. So if I were looking at a confidence interval here, one side would be negative and the other side would be positive, meaning 0 would be in between the two. How do I know that 0 is somewhere in my interval? Because I failed to reject. If I had rejected the null hypothesis, then 0 would not be in the interval. There would be a clear difference between the two. This is why we said you can kind of run a hypothesis test by looking at the confidence interval, looking to see whether or not that confidence interval includes 0. Okay, guys, this will help you with doing hypothesis tests for comparing means. Please let me know if you have any questions.